All right, so for today, for anybody watching this, just so you're aware, we have decided I'm going to post the entire key with where the points come from onto the Google Classroom at lunchtime today, so here in like 20 minutes. And right now, before we start working through the problems, we're going to go through a few that I'm fairly confident that everybody got correct, just to verify your answers. So check it out. One of them that you guys told me was number 2. And in number 2, we are trying to use long division to determine if this is a factor. So very clearly, and I don't always give you this because if I did, you would obviously get some of the answers, but there's 3 points here. The first point comes from, did you indeed use long division? Notice, I didn't say, did you get the long division right, just did you. My quotient is 6x plus 3. Is your quotient 6x plus 3? Okay, that wasn't the full point. I could have done the point here. Did you all get a remainder that is 17? Okay, if you got a remainder of 17 and use long division, the fact that it's 17, it's not a 0, means what? Boom. Therefore, it's not a factor. We all have the same thing. Now, I'm just going to keep a list on the board behind me. Long division, yay or nay? Is that a problem that we're going to have to work through? So that was a weird way to word that question. How do you feel about long division? Thumbs up is good, thumbs down is bad. Okay, so we probably won't do a long division, just purely long division. Cool. How about number 4? Sorry, I meant number 3, but you're okay to turn. Any other, let me just do this. Any others that we don't think we really need to check? Like, we'll check it, obviously, but we don't have to work through every single problem unless you want to. That was the only one that everyone's really confident about? Number 3 was the only one that everybody's super confident about. So, oh my gosh, I keep seeing this, and this is why I said number 4. Number 2, everybody was confident. Does anybody have another problem that we think we're all confident with? Okay, so couple things that we can do. Now, in my mind, we could work through everything here, or we could check the answers here, and then if I do this, you'll now have all the answers, and then we can look at a similar but different problem so that now you have this exact answer on the key, then another identical problem but with different numbers in your notes today for practice. Or we could just rework this exact problem. But if you found this is your standard form, and here's your vertex, and this is your axis of symmetry, and here are your roots, if you have all 4 of those, maybe we don't need to work this exact problem together, but we can. Yes, ma'am. Like this exact problem? For sure. Okay, so looking at it, we're going to work through this problem, and I know that I'm going to work it on the other one, just so you know, but we have g of x equals, and I have the memory of a goldfish, so I'm going to need you guys to go ahead and tell me what g of x is. This is from the practice exam, and it's number 1. 4x squared, and I can see it now. I don't know why I didn't just look down, but thank you. Okay, and it says it's 1a. What do you think previous versions of this quiz had? If there's 1a, probably 1b. So I know that there's exists at least one version of number 1 throughout the years that had a and b, where they had to do this twice. Bless you. Okay, so here we go. We want to write this in standard form. We want to identify the vertex, the axis of symmetry, and the roots. The roots are the only weird part of this problem, in my mind. Now, you might disagree because finding the vertex form is kind of ugly. We get to complete the square to find vertex form. Okay, when I work with a perfect square trinomial, there's many that exist that are not a leading coefficient of 1, but for our purposes, we said let's make it a 1 so it's easier to work with. Is the leading coefficient currently a 1? It's not. What is the leading coefficient? So it's a 4. What could I factor out of that, or divide it by, if you'd rather think of it that way, to get it to be a 1x squared? Cool. So you do not have to include these annotations as detailed as I am. Well, I'm going to say factor a 4 from which terms? Say that a lot louder. So x squared, sure. Any other terms? The x terms. Anything with an x is where we're going to factor this out of. And it feels weird to do, and it's not the only way to do this. We could divide everything by 4 and still do the problem. But unless you really want to do 13 divided by 4, we should just do it the other way. Okay, So there's my step one, right? Factor that out. Do you want, like, it's so weird because you guys all have the answers on your page right now, whether you knew how to do it or not. Your group was probably able to get through it. Do you want me to just pretend nobody has any answers? And we'll just call them people like normal? Here's the deal. Everybody has this problem, and you probably already know if it's right or wrong. Do me a favor. If you are working this again, do it on a separate sheet of paper, or just cover up your other stuff. But I want, when I ask you guys stuff, I don't want to say, hey, what's the next thing? I don't want you guys to go, oh, it's this, and just tell me what's on your page. I want you to replicate this process, right? Like, let's think it out. So, cool. I have a 4 out front. Who wants to tell me what stays behind then? X squared? 3/4 x. Now, when we did these the very first time, that first day, we did a lot of steps here. I'm going to shove several in one here. If you want clarification, I'm here at lunch. I'm here after school for at least a bit. I'm going to leave an awkward gap here. What goes on the outside still? Yeah, we didn't lose it. It still hangs around. For what reason would I leave a big awkward gap here next to the x? So I like most of what I just heard Addison say, and more than one person said it. We're going to take b over 2, and we're going to square it. Now, right off the bat, 3/4 over 2 sucks. I don't like it. But I don't mind treating it a little bit differently. Dividing by 2 is okay, unless it's a fraction. What's the same thing as dividing by 2? So I'm going to multiply by 1/2. Now, what I heard people say was add b over 2 squared. And subtract. What am I really adding to this? 0. And if it wasn't clear when we did it, like the very first time, I'm only doing this because I'm only manipulating one side of the equation. Normally, we don't write add 0. We just write +5 and +5 on both sides of the equal sign. But because I'm only changing one side, I don't want to mess with the other side anymore. So the only way is to add a 0. Okay, so we're going to take b over 2 and square it, or b times 1/2, if you will. So here's my little annotation. No, you're okay. I don't think so. I did not. You guys, real quickly, do me a favor. Come up here, grab your phones, and check to see if you have an outgoing message. I did not, so that's good to know. Was it like right between passing period? Do you know the time? 5-7 minutes ago. It would have been during class. The only people that were here that weren't in this room are Davian. They went on the field trip. Yeah. Okay. Yeah. Sorry. I wish I'm glad it was nobody in here for the record. But okay. All right. Why did I write? Oh yeah. Add and subtract is what plus or minus there, right? Okay. Now it's b over 2 squared. But in this case, b is what? 3/4. And then instead of dividing by 2, it's much easier to multiply by 1/2. And we square it. Now, I'm going to add this one on this previous line, and it makes it look weird with the annotations and stuff. But here we go. What's 3/4 times 2? Sorry, 3 over 4 times 1 over 2. 3/8, and let's square it. So 3 squared is 9, 64 squared is, 8 squared is 64, my bad. If I add it, I'm going to subtract it. Now, here's the weird part of these problems. I think that we can all agree right now that I've just added 0. Like, that's not in question. I've added 0 by adding 9/64 and subtracting it, right? Okay, if I make the following claim, I actually added and subtracted 36/64. Do you agree with me? We wrote 9/64, but I'm going to claim that really, in the whole grand scheme of the problem, I've added and subtracted 36/64. Can you guys tell me why I make that statement? Everything in those parentheses has to get multiplied by what number? The 4. So like right now, if I cover up the 4, it just looks like this. But when I realize that they really do get multiplied by that in the end, I could argue that that's really what came out, or what I added and subtracted. I don't want one of these inside. I don't want the negative because we need to be able to take its square root. So to do that, how do I get it out of here? So I'm going to say distribute, and I'm going to shorthand this. Distribute the 4 to, and in this case, and just this one, right, because this is a specific problem, negative 9/64, and remove. Now, I'm not going to finish that, but remove from where? Parentheses. So let's do that. Here we go. It equals 4 still out front, haven't lost it, and x squared plus 3/4 x plus 9/64. So I kept the positive in there, but I'm doing this distribution. Now, I have no issue if we do this on the first one. 36/64 comes out, and we add 13. This bugs the heck out of me, though. Like, even just writing it now felt wrong. Why? It's not simplified. Now, I don't know how you guys do it. Do you get 36/64 and then simplify? Okay, I just do it right out from the get-go. I see that 4 and looks like 16. I know this is going to be 36/16, and I would simplify it from there as needed. I'm okay with this for now. Okay, we'll clean it up on our next step. Here is now perfect. Not like colloquially perfect. It's legitimately a perfect square trinomial. Does this thing factor? How do you factor a perfect square trinomial? I heard it at, and then it stopped. So take the square root here, x, the square root here, which looks ugly, but I promise it's way nicer than the decimal. What's the square root of 9/64? Yes. PST, perfect square trinomial. Because this process that we just did, this adding, is completing the square, and it completing the perfect square trinomial is what it really is. Okay. Square root of the first, square root of the last, and I didn't get a clear answer here. 9/64 square root, love it or hate it? If you're struggling with it, you probably hate it, but you won't. What's the square root of 9? What's the square root of 64? 8. Okay. What's the sign on this middle term? Plus squared, and then at this point, I don't really mind. You can play the fraction game, or if you guys had like access to TI-84 calculators, maybe, which everybody in here does, I believe. Do you have yours handy? Because mine up here is dead. Yes, for every, great question, Basil, for every perfect square trinomial, and the reason that we do this is because every time it's going to do this. All we do is take the square root of this, the square root of this, and then we use this sign. So it's still in here. It's no different than if we did factoring by grouping, which it just doesn't look as nice. If we FOIL this out, we're going to have a 3/8 x plus a 3/8 x at some point, which that's 3/8 plus 3/8 is 6/8, which is, it's still here. I'm just rewriting it. Now, the easy part for confusion is no different than if I had this 18 on one line, and the next one I said, let's say it was here, 3 times 6. Somebody might say, well, what happened to your 18? Well, nothing. It's still there. It's just hidden within, right? Yep, cool. Now, what I'm going to use this calculator for, though, is I'm hopeful that everybody in here is comfortable with fractions, but I'm not really here to teach fractions, right? Like, obviously, if we have a deficit, in our ability to do fractions, we'd cover it. But can you guys all add and subtract fractions? Cool. If you can, and you're being honest with that, then I don't know that I really value the time spent doing it. So here's a cool thing. Negative 36/64, and we'll turn the, here it is, negative 36 over 64, and I'm adding 13. Well, it's 12.4375. Well, that's not what the frac I want. Notice I hit the math button, and I'll go back to that one. I hit math, and what's that first thing? Frac. And I say, hey, frac this, and it says, okay, and it's 199/16. I don't care, like, I want you to be able to do it without it, but in the interest of time, I have no issue with this, 199/16. At this point, I'm in vertex form. Like, we're there. I have my vertex form. Now, it's called vertex form because right off the bat, from this form of this quadratic equation, which I just want to specify, this and this are the exact same thing. They're just different forms. Okay, one of them sucks to graph, this one. One of them is super easy to graph, this one. And if you don't see why that's the case, hopefully we can clear that up right now. What is the vertex of this? So I'm going to write something over here. Our vertex form in its most general looks like this. Does anybody recall where our vertex is in this form? H comma K. Now, notice we didn't say negative H, we said H. If this is a plus, we must have subtracted something, x minus a negative. So what's the H value in this? Negative 3/8. And the Y value, the K? Here is my vertex, which is something I was asked to find. Cool, we have it. For this next part, the axis of symmetry, I'm going to sketch a graph. It's not this graph necessarily, just for the record, but I'm going to sketch a graph of any quadratic. Here it is. Here's my vertex, right? If I wanted to graph this thing quickly and easily, do I really need points here and here and here and here? How do we graph them so we don't need all those points? Because I definitely do need them, but I don't think my table is going to have 5 points on it. How many points did we use way back at the beginning of this chapter? 3. I used this point, and it doesn't really matter, this point and this point. Those are the only 3 that I used. How come I didn't need to get these ones? Because it, what? It reflects, right? Over which line? How would you draw? Is it this line? No. Where is it? And it's called the axis of symmetry. I'm going to draw a vertical line. Where do you want you shout when you're close? How'd you know it's here? It runs right through my vertex. Can you tell me the x coordinate of my vertex? So check it out. There it is. It's a vertical line that runs through it. There is that vertical line where x is always negative 3/8. Cool. All right. The last one is the ugliest part. And this, I promise, if it shows up on the test, will not be nearly this challenging. I think it's reasonable for a practice test with collective minds to be a little bit harder. Hope you agree with that. You might not. So here we go. I need to find the zeros, right? Is that the last part? Roots? Cool. I said zeros, but it says roots. Okay. Last little piece here. We get 2 options. We can either deal with this form that we found at the end of our problem, or we can deal with the exact same thing in a different form up here. But either way, if we're looking for the roots, we're going to set it equal to what? 0. Which one did you guys go with out of curiosity? Did you start with the original and then you factored this? So I see a mix here. And check this out. We're going to get the exact same answer, and whatever's ugly from one form is going to be ugly in the other because we get the same answer. If I tried this one, walk me through my factoring list real quick. What's the first thing we always check? I'm looking at the red one for anybody watching the video. Is there a GCF between 4 and 3 and 13? Bummer. Okay. Is it a binomial? No. It's a trinomial. What's the leading coefficient? Well, there went my shortcut. I might check for a perfect square here. Do you know the square root of 4x squared? 2x. Do you know the square root of 13? All right, so it's not a perfect square, which means we get to group it. If I take 4 times 13, I get again, I'm not your multiplication teacher. 52. That was my hint to say use your calculator if needed, right? Okay. Factors of 52 that add up to 3. Well, it's not 1 in 52. It's not 2 in 26. It's not. Does 3 even go into it? 3 doesn't even go into it. Well, it's not 4 in 16. 5, 6, 7. 8. I can't do it. Bummer. So if I can't do that, what do I have to use? We could use a quadratic formula. Now, turns out that completing the square is how you get the quadratic formula. We've already completed the square. We've done the hardest part of this problem. If you solved it with the quadratic formula from right here, that's completely fine. You're going to see the same answer. I'm going to suggest we use this one. So all I'm going to do is I'm now going to take this, my quadratic just happens to be in this form, and I set it equal to what? It says 0. So here we go. And I want you guys to help me solve this. Okay, so it's just like every other equation, right? We're not factoring to solve. We're just going to solve it as normal. Now, isolating the x is a goal. I'm going to move this over by subtracting 199/16 from each side. So here we go. I subtract it. Equals 4 times x plus 3/8 squared. Now, I'm still trying to find x, right? Do I have stuff that's not an x term on the right side still? Now, some of it's inside and has to be squared first before I can do anything, or we have to change that. Alternatively, there's one other thing I could do. Okay, you're going to say divide by 4, and I'm good with that answer. I'll write it this way on this side. On this side, there's not a chance that I divide by 4. I multiply by 1/4. But are these different operations? No, they're the same. They're gone. And let's see here. This is negative 199/64 is now equal to x plus 3/8 squared. And it feels different than the quadratic formula, but here in just a moment, you're going to see the exact same piece of the quadratic formula. Like it's going to be identical. I want to solve for x, but x is stuck inside a square. I'll take the square root. I'll do the right side. Piece of cake. And I'll add this in here. It's going to be in this ugly, actually, I thought that was going to be hard to see. Can you guys see that well? So it's kind of hard to see. Okay, fair. It's really clear on my screen. I don't know what the square root of negative 199 is. Anybody know what it is? Gosh. Well, can you give me any two numbers that you guarantee multiply to be negative 199? Give me the obvious one. I could do 1 and negative 199. Could I also do negative 1 and 199? I'm going to take that. Why do I want to envision this as negative 1 times 199? I, right? So I'm going to sneak a plus or minus there because I haven't written it yet. But I know it's going to be I root 199. And I'll put my plus or minus on. How about the denominator? Do we know the square root is? Okay. No, I'm good with it. No luck?
No, but can I ask the kids to look in your phone? Can you grab your phones and see if you have a 3592701 listed as a friend? 351? What was it? 3592701.
All right. Well, shucks. Those of you that might have used a quadratic formula, which I think there's a couple, did you wind up with negative 199/64 at some point? Like you had to take a square root of that? I'll look again. If you use a quadratic formula, you're going to see the exact same numbers. They're just going to show up in a different order as we go through it. I'm one step away from solving. Suggestions? I will subtract 3/8 from each side. And here we are, negative 3/8 plus or minus I root 199/8. Now, realistically, if you did the quadratic formula, it's going to look like this instead as a single fraction, but it's the same value. Cool. Yo. You're good. Yep, absolutely, you're good. Whether it's out front or in the numerator, they're the same thing. Cool. All right. So on the first one, and this is a super weird way to do it because I had some people handing it in today, and then they happened to be gone, so I couldn't give it back to them. I'll look at your quizzes again. I'm not like crazy opposed to you guys taking them if you want your own physical work. I'm not a huge issue of mine. But if you want, and I would appreciate it if you haven't done it yet, give me some points here. Did you get standard form that is this? If you did, that's a point. Did you get this as your vertex? If you get this as your axis of symmetry? And did you get these as your roots, which is what we just got? Now, the weird part and why I try not to make you guys grade a ton of your own stuff is that if somebody drops the ball and makes a silly mistake right here, whatever, it happens, right? Is there any hope of getting the rest of them right if you have a mistake here? No, and it sucks from my point of view, but if somebody has a minus sign here instead of a plus, they're going to have all different answers. I just want to make sure you recall, I will redo the problem with your wrong answer and verify we still get all the same stuff. Because if you're doing everything right here and you just happen to have the wrong equation, it's not a -4. That doesn't seem fair to me. Like I try to always give you guys as much as I can, show the work, and I can always do that. Cool. Questions there, issues with this problem? Okay, so number 2 we already checked. Number 3, if I want to find all the real zeros, what's the first step? So maybe, and like you're ultimately right, just so you know. Okay, so here we are. I want to find all the real zeros of this. Now, again, if you guys want to come work more problems with me, am I going to tell you no? No, but I also do want to make sure we have enough time to talk about all of them today. So we're going to go quickly. I would have to start by finding the zeros of this. Now, I heard somebody say it yesterday, I don't recall who, but if I see a 4-nomial here, which there's 4 terms, right away my brain's going to look for what? Grouping. Now, if I did a grouping, I could take an x squared out of this, and it leaves 2x plus 11. Can you take anything out of these to leave a 2x plus 11? No. Okay, so grouping's dead. Now, whether or not that's really true, I might try to rearrange these and see if I could do it the other way, but it still doesn't work for the record. So it means we have to find our roots. Okay, for our roots, and I'm going to jump in with this problem because I wrote way less than you guys did. If we're trying to do number 3, and we get this lovely equation, I'm going to write it as y because it's simpler. 2x cubed plus 11x squared minus 21x minus 90. I don't know where to even start looking because I could look at 1 or 0.1 or 0.11. Like there's infinitely many choices. So it'd be nice to be able to narrow it down somehow. Well, if there's a way to find the possible rational roots, that'd be helpful. It's plus or minus, and I heard P and Q. What is P? It's a factor of 90, the constant term. And really, we said factors because we have a lot of them, but it's going to be a factor of 90 over a factor of what? The leading coefficient, which in this case is 2. So this one, I'm not going to write them all out. I'm just going to find the first few, and if I have to come back and finish the list, we will. But let's go ahead and start. Factors of 90. A 1 goes into it. Does a 2? Does a 3 go into 90? Does a 4? Does a 5? I'm going to pause here, and I know there's more numbers. I'm just going to stop here first. Okay, over, what are the factors of 2, my leading coefficient? 1 or 2? Now, on the calculator, do we need to review how to see these on the calculator? So I'll grab a working calculator. If you guys aren't sure, there's a couple ways that we can do this. On the one that we did in class with a bunch of numbers, I showed us a shortcut that you guys seem to recognize from last year, which is awesome, but it's not the only way. So what I'm going to do is I'm going to type this equation, y equals 2x cubed, into y1 in my calculator. So I hit the very top left button. I'm just going to type this in before I do this. Minus 21x minus 90. And I did it all in the exponent because I didn't look down. Like just now, if you notice the face I made, that was like the most angry I've been today, easily. Cool. All right, so all I've done is I've typed in that same function, 2x cubed plus 11x squared, so forth and so on. Right here, we're going to turn this way up to see it. Okay. If we have this typed in, just to verify, cool. 2 ways to do this. I'm going to go back to the home screen by hitting second quit. And then the 2 options. I can either just treat y1, which is what we just typed in here, like a function, and I can say y1 of whatever. Or, anybody recall the other way we did it in class that day? Okay, so if we want to do it like y1 of or f of, I'm going to hit the vars button right here. And it pulls up this screen. Now on the top, there's 2 tabs. There's vars and there's y vars. When we just typed this into our calculator, it was a y variable. I'm going to hit 1 to the right, and it goes to y vars. I then want to treat whatever I just typed in into y1 like a function, so I'll just hit enter. What was the name of the function that we just typed in on the very first one? y1 or y2 or y3? y1. And now we're going to start using our calculator and all those PQs that we just found to check. Now, you could use Descartes' rule of signs if you wanted to get a kind of heads up with this, but it's not required. If I look at these And if you're not quite sure what these numbers mean, there's more here. But all this means is 1 over 1, or 2 over 1, or 3 over 1, or 5 over 1, and so forth. And then I get through that whole list, and I could say or 1 over 2, or 2 over 2, and blah, 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 right? Okay, what do I want the remainder to be, or the value to be, if it's an x-intercept? I want it to be a 0. So I'm just going to start. If I want to know f of 1, or y1 of 1, I'm just going to type it in and not hit minus. We'll just hit enter. Is that 0? Okay, so 1 is not a root. If I hit on my calculator second and then just enter again, it just brings up the line. What was the next number in our list? I tried 1 over 1, 2 over 1. Is that a 0? No, bummer. Is it getting closer to 0? So I see I'm at least going the right direction. What's the next number on our list? 1 over 1, 2 over 1, 3 over 1. If I do it again, second enter, and I'll just change that to a 3, is it 0? That tells me a ton of information. What did I just determine? X equals 3 is a root, and alternatively, what's a factor then? X minus 3. Now, the way that we did it another way in class, and I don't want you to do this every time, and really, I don't care if you do this every time to find it. Instead, I know that a lot of these numbers have 1 in the denominator, right? Like, because that's one of my options. If I go to my table, I'm just going to look. Here's one that happens at 0. Okay, none of the other ones are going to be positive whole numbers, and I can tell that. If I went backward, I could go and find probably another negative here. I bet, oh, it's between these. So I know it's between -2 and -3. Bless you. I'm going to use the 3 because that's the first one that we would find. What do I do with the fact that it worked with 3? Divide. What do you mean? So kind of. I like your idea is right. I guarantee it. I'm not dividing by 3. I'm dividing by x minus 3. Now I'm going to use synthetic division, and that's probably where that language is coming in. I'm going to double check it with my synthetic division because if I typed it in wrong, I'm going to destroy my problem. What should the remainder be when I do this? It should be 0. What numbers go here? All right, so let's see if we're right. It's a 2, and then 2 times 3 is 6, and that is 17, and that is 51, which feels prime, and it surprises me every time. That's 30, that's 90. Is it 0? Okay, so how we go through this, it depends on the problem. For me, it really doesn't because it was right at the same. My immediate next line, now that I've decided that x equals 3 was a root, I would rewrite my function in its factored form to wherever we are. My first factor comes from x equals 3 as a root. And what was that factor again? X minus 3. And the other factor has these coefficients. 2x squared plus 17x plus 30. Now, I view these problems as factoring problems, whether I'm solving or not, because factors and solutions are same versions or different versions of the same thing. I now need to look. Can you guys factor this one any further? I can't either. Can we factor this one further? Now, in the interest of time, just to ensure we get through it, this is a grouping problem if I've ever seen one. Group it, and if you want help with the factoring, reminder, I'm here like all the time. I believe this factors down to 2x plus 6 and x plus 5. Now, notice there's a GCF here, and maybe you take it out in a different order, and you might have slightly different factors. But if I have all 3 of my factors, which, again, I didn't show the factoring, right? If I set this equal to 0, the first factor, what do I get? If I set this factor equal to 0, x equals 3. If I set this factor equal to 0, I'll subtract 6 and divide by 3. Whoa, subtract 6 and divide by 2, I'm sorry. So I think 2x plus 6, I said it equal to what? Am I wrong? So we'll get there. Is it 2x plus 5? Did I factor wrong? Oh, yeah, I didn't change it. Casey's group, you showed me that I was wrong yesterday, and I just didn't change it. Okay, don't trust that factoring. The actual factoring is 2x plus 5. And then what's the other one? X plus 6. Thank you. Sorry, I didn't even make a note. I'm going to make a note now. Change this. But then I'm going to see it again. I'm going to change it again. So we'll see. How about this one? -5 and then divide by 2. And then this one, -6. And we have it. Cool. The factoring part. I don't see my mistake right this second, but I will. Cool. Feels all right? Feels terrible? Okay. We're going to have to go a little bit quicker through the next ones, but with the understanding that I'll be here till like 4 or 4:15 today. So if you want like specific one-on-one help with it, like anything specific, just let me know. I'm here. Like we can work through problems. Okay. I will also post a detailed key. It just doesn't have all the annotations. In the interest of time, just to make sure we can hit them, you guys are going to stop me and say, hey, I need you to explain further at particular parts, okay? All right, on number 4, you can write the lovely as x approaches positive infinity and negative infinity. I love it. I would prefer that for like the true math. For grading it, definitely this. Up and up. It's a positive 1x to the 4th. X squared goes up and up. I know that x to the 4th will also. Cool. All right. If x minus 1 is a factor, notice there's another one hiding here, and this is a strange problem. I didn't give you the fully expanded thing, right? This is already one of my factors. What value of x makes this 0? 0. And then I even give you another one. I tell you that 1 is also a factor. Now, what's weird about this is you probably have the same coefficients here, whether you notice that or not. But you might have, if you distributed that through, you would have another 0 over here on the end. Like you would just find a slightly different factor. Now, x equals 0 was a root. I noticed that from the very beginning. And then I use x minus 1 to factor the rest of this piece. Here are my coefficients, 1x cubed, 1x squared, minus 5x, plus 3. We synthetically divide, and I confirm that x minus 1 was a factor, or that x equals 1 is a root. I now have x equals 0 and x equals 1, and then I just have this thing left over. Does this factor? Factors of -3 that add up to 2 for sure. And here they are, x plus 3 and x minus 1. So I always will write this, and I don't leave off pieces because I'm afraid I'm going to leave them behind. I had x minus 1, x plus 3, and x minus 1. I have 4 total roots. Here they are. You got 4 points on this problem. Did you synthetically or long divide? Did you get this as your quotient, and did you factor it further to get the 4 total roots? Did I know that this thing, and did you know that this thing had 4 roots before we started? How do I know that this is going to have 4 roots? Because it's x to the 4th, right? If we distribute, and oh my fundamental theorem of algebra. That's what it is. Cool. All right, to sketch it, should we sketch it together? Okay, so I'm just going to sketch this one. I'll do it like on the same thing. I will not give you such an ugly bold graph tomorrow. I hated it, but it was too late for me to change it. So here we go. Here's my lazy graph. I'm not even really going to put scales on here. Where are my roots? So -3 lives there. 0 lives here, and 1 lives here. I'm going to look back at this real quick. Did any of them show up an even number of times? It is. Speaking of faces with square stuff, when you drive by my house, look at my sweet creeper pumpkin out front. It looks pretty good. Like, I'm kind of proud of it. All right, check it out. I cross at -3. I know it ends up and up. So I'm just using my end behavior. There's my arrows that I drew. I know it crosses here, and it turns and, bounces here. So I'm just going to draw that bounce here first. It bounced. And then what's it do here? Crosses. Now, I don't know how far it goes, right? It could go all the way down here, or it could just go to here. Don't care if we're just sketching it. I know it crosses, and they meet up somewhere in here. Here's the graph that I just drew. Looks very similar, a little different to the one that I drew the other day. It would look slightly different every time. Yes, miss?
Sorry, it's really late, but back where we factored, or there was x, the parentheses x minus 1, x plus 3.
Yes.
I understand where the x minus 1, x plus 2, but I don't understand the other x minus 1.
So this is the one that we started with. They said x minus 1 is a factor. This synthetic division right here is us dividing by x minus 1. So when I got 0, it's here. And that one you're cool with? Okay. Can you tell me numbers that multiply to be -3 but add up to a 2? -3 and 1. So what's the leading coefficient of this trinomial? So do I have a shortcut for factoring? So if that is a 1, and you're right, there's a shortcut for factoring. One of my numbers was a -3. So here's my x -3. The other one was a +1 or -1? Do I have a typo? It should be +3 and -1. Yeah, that's my bad. So there's my x + 3, and then x. Yep, and I just used a shortcut. If you want to factor with grouping all the way through, you can, but the shortcut with the leading coefficient, always useful. Yep, so here's 1. Here's the other one that I saw just out front in the beginning. Here's the 3rd and the 4th. Yep, and we happen to have one that repeated, which is fine because it just means I bounce. All right, this one. Sorry if that was really loud because I looked down and then I shouted. Division number 5 feels okay for everybody or not super? Sorry today's so boring. I can tell in some of your eyes. I'm having fun, but I'm just going to check. You used the conjugate. There's a point. If you did it, you got it. 4 minus I and 4 plus I. Don't forget there is a shortcut. 4 squared plus 1 squared is 17. Cool. I just FOIL out. We clean up. I squared is what? -1. So when I have 24 plus 10 minus 1, there's my 23. Sweet. On this one, we just FOIL and we clean up our I squared. 23/17 plus 10/17 I, or 10I over 17. If you gave me the fraction here, I'm going to give you the credit. But with complex stuff, you should always try to write it in A plus BI if possible. All right. Number 6. Sweet. Okay, same thing. We're just going to go through it to make sure that we can see this. I will post all of this, and I can try to add some annotations to this. But check it out. When I do these problems, rational inequalities, it's no different than when I do a linear inequality, except now we might have to consider the asymptote stuff. Right off the bat, I see this expression and I wonder, is there an easier way to view it? And the question is typically going to be a yes, and the easier way to view it is to do what to the numerator? Like this sucks-ish. And you might think this sucks-ish as well, but I think this is way easier to think about. And we're going to have to do it anyway. Factoring was the answer, just so you know. I'm going to simplify it if possible, but I'm definitely going to write everything factored so I can see stuff. Do we all agree that less than 0 means negative? Now, this question I've asked a billion times. I guarantee I'll ask it a billion more. When can a function change signs? Roots or asymptotes? Fun question. Is there a third place? Okay, yes, there is. If there were a hole, would be the other place, just for the record. I was waiting for somebody to ask, but okay. So I factored it, right? Leading coefficient of 1. How do you find the roots of your rational function? Or if I reword that so it sounds less fancy, but it's the exact same question, what make fraction 0? When the what part is 0? The numerator. If I take 0 divided by something, it's always 0, right? If I happen to have this in factored form, can you tell me what values of x make my numerator 0? 4 and 5. Those are my roots. What make me divide by 0? 0. And that is indicative of a what? An asymptote. Just to be clear, indicative is just a fancy version of indicates, if that sounds too fancy. Cool. I have a vertical asymptote. And I just want to ask one more time, when can a function change signs? Roots or asymptotes, and we just found them. So let's just put them on a number line. So here we go. I put 0, 4, and 5 on my number line. I don't really test the intervals. I heard somebody yesterday plugging in 4.5, and it had to bite my tongue to not come and tell you to stop. You can. What value is the easiest to check in any of these intervals? So interval 1, interval 2, 3, or 4? 2 is the right choice. And the number is a 1. That's the easiest possible number. If I plug in 1 to this, I see a negative times a negative over a positive. So again, I don't care about the number, but I plugged it in. I got a negative times a negative over a positive. Also kind of looks like a face. Negative times a negative is divided by a positive still means, check it out, it's positive. Now, there's one more value that we have to check. I don't think it's in here. I never have to check 4.5. This was a root, an x-intercept. How many times did it show up? Once. That means it's an odd number of times. It's an odd multiplicity. It crosses. If it was positive, now it must be negative. This was also a root that showed up once, an odd number of times. If it was negative here, it must be positive. And we're going to use that like over and over and over and over and over. We did this in calc yesterday with a different reason, but the exact same approach. Why can't I use that same trick here? That pesky asymptote. Can you give me a value to check anywhere between negative infinity and 0? Good choice. Let's see. Negative 1 minus 4 is a negative. Negative 1 minus 5 is a negative. So my numerator would be positive. Divided by this negative downstairs, it's a negative, and I check it. The graphing part, I'm not going to require you guys to do, but if you struggle to write the set or the interval, this helps, I think. If I'm seeing where it's negative, I see it's everywhere here, and then everywhere here. Here is my answer in set builder. Here is now my answer in interval, but really interval notation is just a cool way to do set builder. Red. Yes, I'm going to count you wrong. And here's the reason. Give me a number that's less than 0 and greater than 4. Like you can't, right? Like there's no way to do that because they're at odds with one another. If you're ever wondering the word there and you're not confident even with that little thought there, I would just switch to interval and use union. Cool. All right. Cool. Issues? Feels all right? Sorry it's so boring today. I can tell some people are. But if you've already done the test, it's not going to hurt you to look at the problems again, I don't think. Sweet. This one. Every time, I don't like this. I'd like it to be easier. Or nicer. What do I mean by nicer? Factor it down. Check it out. I factor the numerator and the denominator. Cool. There are 2 points. First, did you factor? And the second is did you simplify, right? So I was trying to make a joke, but nobody, all right, that's fine. Cool. This falls out. Now, immediately, don't just forget about it. Like, I'm fine with using this easier function to think about, to graph. That's what happens. But the fact that it fell out, was there a value of x that would have made me do 0 divided by 0? If x were 1, because this is my factor that fell out, I would have done 0 divided by 0. And are we allowed to do 0 divided by 0? No. Now, that shows up very specifically, and it doesn't show up until part D. The factor that divides out, or the root that divided out, if you'd rather say it that way, is a hole in your graph. Every time. If it divides out, it's a hole. Okay, so once we're here, can you tell me the zeros of this function? I'm covering up the ugly part that we don't need anymore. What makes a fraction be 0? The numerator 0, the denominator 0? And what makes the numerator 0 here? Because I agree with you. 4. Check it out. I have a root or an x-intercept at 4, 0. What makes me divide by 0? What value of x? -1, and that is my asymptote. I'm there. Cool. And then the domain, even though we removed it, right? We can never use it. There's only 2 things that made me divide by 0 anywhere. It was 1 or -1. And I have a typo or an omission, not equal. All x's that aren't 1 or -1 are cool with me. Okay, the last little piece, the only thing, it doesn't show up in any other part of this question, there's a horizontal asymptote at 1. How did we know it was at 1? The ratio of the leading coefficients, because Aisha says, she whispered this, and you guys might not caught it, but she said, Mr. Holloway, the degree of the numerator is 1, and the degree of the denominator is 1, and then for a rational function, if the degree of the numerator equals the degree of the denominator, it's a ratio of the leading coefficients. I don't know how you said it so fast, but I love it. Cool, it's 1. Then we just put it all together. Disregard my wrong asymptote here. I just graph the graph as normal. I will then go back, I'll erase, and I'll put a hole here. This is not really an asymptote. I just can't draw the lines. Cool. All right. We have 10 seconds, quick vote. I would like to take the test tomorrow. Thoughts?
What's the other option?
I come up with a backup plan and we play Jeopardy tomorrow.
Jeopardy.
So keep in mind, will you study over a long weekend, or are you going to do what every other student does and say Monday when you walk in, crap, I forgot there was a test, I didn't study, and now I'm less prepared than I would have been last week? Okay, we're playing Jeopardy tomorrow. Cool. I don't know what the prize will be. I'm going to keep your team test now then. Cool. For anybody who's traveling and watching the video, hopefully your classmates will tell you the same. We're taking the test on Monday, not tomorrow, Monday. If you're traveling and you're getting back on Sunday, in class on Monday, you're going to take the test. Cool.